Okay. Well, let's go ahead and get to it. I passed these notes out yesterday, so we have a little two-dimensional geometry that has a few additional topics you haven't seen in a while. And again, we'll get to spiral in, some more of those linear functions, all that good stuff. But we did decide yesterday the homework is due. Okay, Thursday. Okay, so tomorrow when I'm gone, I'll have a little functions and their graphs worksheet for you to go ahead and take a look at for additional practice on that. In fact, I've already uploaded the key to the website, so as you go through, you can see if you're getting them correct or not, and if not, ask me a question when you get back. But on Thursday, we'll grade the homework, talk about any questions you may have. I've got an exit ticket, and hopefully we'll be finishing up this set of notes by Thursday. If not, we'll finish it up by Friday, and we'll continue with Trig the next time. And then on Friday, what's happening? Quiz. There we go. So the quiz is going to be over linear functions and the quadratic functions. All right. So again, the focus activity, hopefully the exit ticket will give you a little more practice with that. Even the worksheet tomorrow. So, oh, I thought you were looking through. They're right over here. Right here. Okay. All right, so I think that's all I have. Remember, the test is going to be on Monday the 4th, 2 weeks from Thursday. The IA is due. Any questions over any upcoming events? Okay, then let's go ahead and get to it. So this first part I've already got filled in because this is, just the basics, what you're going to see when you first go into geometry. We have the axes, the four quadrants, the origin, XY axis, all that good stuff. Let's get to the formulas. The distance formula, to find the distance between 2 points on a given plane, the square root of the difference of the x's squared plus the difference of the y squared, and the midpoint formula is going to be basically the average of the x values and the average of the y values. Okay, so let's get right into it. Find the value of b, given that we have point A is -4, 3, and b is lowercase b 7, and we're already told that they're the square root of 97 units apart. Okay, so we just want to go ahead and plug in and basically work backwards because we have the distance. Now we just need to know what that other value is. So let's see, it was the square root of the difference of the x's. So why don't we go ahead and go this way to keep the value, the variable positive. So let's say b, what would it be? Subtracting a -4. So +4. So +4 squared, okay, plus now we want the difference of the y's, so 7 minus 3 would give me 4 squared. Now in order to set up the equation so that we can work backwards, I'm going to go ahead and set this equal to the distance that we're told the points are from each other in the coordinate plane. Okay. So now what would I do? There you go. We want to get rid of those radicals, so I'm going to go ahead and square both sides. Okay, they're inverses, so they're going to cancel. That's going to give me b plus 4 squared plus 16 is equal to 97. Okay, and then now it's just a matter of going through and ultimately solving for b. So I would do what next? Okay, so if I subtract the 16, okay, so that's going to be b plus 4 squared is equal to 81. Now I will get 9 once I do the next step, which is what? There you go. In order to get that base b plus 4 out so we can manipulate it, we got to take the square root now. So b plus 4 would equal 9. But we are solving an equation, so there's something I'm missing. Plus or minus. There we go. There actually are 2 possible values that can make this a true statement. Okay, so now it's just a matter of subtracting the 4 over. So one value of b would be a positive 9 minus 4. The other would be the negative 9 minus 4. So I'm either going to have a 5 or a what? Minus 13. There we go. Those are my values of b. Okay, any questions? Easy, right? Easy peasy. Okay, like that. Okay, what else we got? Now, let's talk about some of these linear functions that we've seen previously. Again, in IB, we don't use the word slope. We're going to go ahead and start using the word gradient. Okay, so slope intercept would be gradient intercept, and they just change those accordingly. Point slope would be point gradient. Okay, but we already know how to find the slope. It's the change in y over the change in x, basically the difference of those two sets. All right, now we have the gradient intercept, y equals mx plus. Now we normally say b, but here they have c, so ultimately the variable itself doesn't matter. We also have standard form, ax plus by, and again, they're changing it slightly. We talked about it where it equals the constant, so that changes things just a little bit. You'll notice the ratio for the slope, it's still the opposite of a over b, right? But what we came accustomed to, what was the y-intercept? C over B. There we go. There we go. And they went ahead and put negative because we've got C equal to 0. They've got it on the same side. And then C over A was going to be our x-intercept. So it really just depends on the form you have it in. If you take that ratio, whether positive or negative, you're still going to end up with what you need. The point gradient form, y minus y1 equals m times x minus x1. Okay. But there's one form on here that we didn't really necessarily need, but I went ahead and showed you anyway. The double intercept form. Okay, so that was x over, okay, plus y over c over b, and it equals 1. There we go. And that was double intercept. Okay, so we have our next example. Write the equation of the line that passes through these 2 points in point gradient form, gradient intercept form, and then standard form. Okay, so we're going to go ahead and get one equation, and then we're just going to manipulate it to get the other forms that we want. In fact, I'll go ahead and start out. Let's find the slope m, which is the change in y over the change in x, and it really just depends on where you want to start. John, do you like the 3 or the negative 5? Negative 5. So we're going to go ahead and run in this direction. So negative 5 minus 3 over, that would be negative 2 minus 4. So I'm going to have negative 8 over negative 6. So my slope is what? Four-thirds. There we go. 4/3. Okay. Now the first one we want is point gradient form. That's this one right here. So using a point and the slope, we want to go ahead and write it out. So let's see. Evelyn, okay, what point do you like? 4/3 or negative 2, negative 5? 4/3. So let's use this point with that slope. Okay. So Evelyn, what would the equation be given that information? For point gradient or point slope. Okay. All right. That's point gradient form. Okay, just using the point and the slope. All right, now we want to go ahead and rewrite that in gradient intercept. So we know y equals mx plus b. They say y equals mx plus c. So somebody distribute for me. So y minus 3 would equal what? Okay, so 4/3 x minus 16/3. Okay, so pretend that 4 is over 1. We multiplied it straight across. Okay. Now I want to go ahead and add the 3 to that. So negative 16/3 plus 3. So we need a common denominator of 3. So what divided by 3 is 3? Okay, 9. So negative 16/3 plus 9/3. And that's going to be negative what? Negative 7/3. Okay. There's slope gradient form, slope intercept. Okay. Or gradient intercept form, I should say. All right. And now the last one, we want standard form. Okay. So even though it has the constant on the same side as both the variables, we'll go ahead and write it as we are accustomed to. So I need to rewrite this as ax plus by is equal to c. Okay. So what would I do first? Ax plus by equals c. Spencer, what do you think? Okay, move over to the 4/3 x. So if I subtract that over, negative 4/3 x plus the y is equal to a negative 7/3. Okay, now what? Okay, what's that? Multiply by negative 1. Okay, so that would be 4/3 x minus y equals 7/3. Okay. Now we're getting closer. There's only one more rule that we're violating. We want to multiply by 3 because no fractions, no decimals. There we go. So if I multiply by 3, let me put this back up here. That's going to give me 4x minus 3y equals 7. There we go. And whether you want to pull the 7 back over or not, again, it's still equivalent. Okay. Questions? Did anybody want to go ahead and take one step further and rewrite that standard form as double intercept? Just for practice, or you think you're comfortable with that? Does anybody want to? Let's do it on the board, okay. So let's see here. If we want to go ahead and put it in double intercept, then we want to make sure that it's in this form here where the denominators are my intercepts. So we can just reverse this idea here. You remember the idea, if you're dividing by a fraction, then you multiply by its reciprocal, right? Okay. Well, you can also reverse that idea. If you're multiplying by a fraction, then that's the same as dividing by its reciprocal. So if I'm multiplying by 4, this will be equivalent to x over what? Okay, 1/4. Okay. Actually, what the? Yeah, I got ahead of myself because I forgot one thing. Remember, in double intercept form, it has to equal what? So my rule was correct. I just forgot to go ahead and divide through by 7 first. So this would be 4/7 x minus 3/7 y is equal to 1. Now we'll go ahead and divide by the reciprocal. Okay, so I got a little ahead of myself. So that's x over 7/4. And I'm going to go ahead and keep the minus there. Y over 7/3 equals 1. Yeah, C divided by A, there's your x-intercept. C divided by B, there's that. Now you can either say plus and keep the negative on that denominator, or I just pulled out in front and kept it as minus. Either or. And there we go. Questions? Easy? Okay. Well, all right. Let's see what else we got. We talked about these concepts here. Parallel lines, two straight lines are parallel if they have the same gradient. Conversely, two lines with the same gradient are parallel lines. Then perpendicular, if two lines are perpendicular, then the product of their gradients is -1. Okay. We were talking the other day about negative reciprocals. So you flip it and you change the sign. Okay. So given a system, determine whether the two lines given are parallel, perpendicular, or neither. And we want to do this without solving. Okay, just what we know about standard form, we want to go ahead and take a look here. So first line, 2x minus y minus 5 equals 0. And then we have 4x minus 2y plus 3. So I'll go ahead and do what you guys prefer. If we keep the form as is, then we want to take negative c over a, and we want negative c over b. If we move the constant over, we're still not solving it, but then we have the normal ratios that we previously talked about. C over A and C over B. Carolina, what would you like to do? Just move it over? Okay. So 2x minus y is equal to a positive 5. Then we have 4x minus 2y is equal to a -3. Okay. So let's say this is equation 1 and that's equation 2. So for equation 1, okay, let's go ahead and start with the slope. All right. Well, let's see here. The opposite of A divided by B. So it looks like -2 divided by -1. So the slope is 2. Okay, let's move on to equation 2. Let's see what happens with its slope. The opposite of A, -4 over B. -2 does give me 2. Okay. So we can definitely eliminate perpendicular. They're either parallel or it's neither. Because what's the other possibility? The two lines could be what? It's the exact same line. Remember, we call that coincide. Okay. You guys remember that? Okay, so let's go ahead and what would recommend we find next, like the x or the y-intercept? I'd go ahead and find the y-intercept. Remember, the y-intercept was c divided by b. So this one here, okay, would be 5 divided by -1. So this would be -5. So this one over here, b would equal, we had -3 divided by -2. So it's 3/2. So we have two lines that each have the same slope, but their y-intercepts are different. So what's that telling me? They are parallel to each other. Okay, there we go. So if I did try to actually solve it using one of our methods, substitution, elimination, we would not be able to get an answer. There are no ordered points, ordered pairs, I should say, x, y, to make that true. Okay. Well, let's get somebody up here for the second one. Who wants to help me out? 3x minus 4y plus 28 equals 0. 4x plus 3y minus 6 equals 0. So many hands. All right. I don't know if I still have it up. Let's see. We only go to 27, right? Okay, so let's see here. Oh, I do have it up. Okay, so we'll change that to 27. So no volunteer. Oh. Okay, Jocelyn is shaking her head yes that she wants to come on up. All right. Come on, what's the worst that can happen? That's fine. Your friends are going to help you. I'm going to help you. Okay. I stand up here every day and don't know what I'm doing, so don't feel any different. Okay. Come on up. I didn't choose you. The computer chose you. It was completely random. All right. Yes. Okay, thank you. Thank you. All right, so let me get back over here for you. Okay. So now what I would go ahead and start first is finding the what? Okay, the slope. What was our ratio for the slope? The opposite of A divided by B. Okay. So looking at our equations, let's plug in A and B. Okay. Now you're right, but B is a what? Is it 4 or -4? -4. Okay. So that would simplify to a what? The two negatives would cancel each other. That's right. So the slope of the first line is simply three-fourths. Perfect. Now let's do the same thing for the other one. Okay. So we want the opposite of A over B. So we have a -4/3. Okay, that's not going to simplify at all. All right, so what are we noticing here? Opposite reciprocals. There we go. Okay. Do we even need to worry about finding the y-intercept? Nope, I wouldn't need to because those are opposite reciprocals. The product is -1, so these two lines should be perpendicular to each other. It's absolutely right. All right, excellent job. All right, yay. Let's give everybody, let's give her a round of applause. Yay. Great job, great job. Okay. And now we have the idea of a perpendicular bisector. The perpendicular bisector of a line segment AB is the line that passes through the midpoint M of segment AB and is perpendicular to it. Okay, so find an equation of the perpendicular bisector of the line segment AB where A is equal to 1, 2, B is equal to 3, 1. Put your answer in standard form. Okay, so how would I begin this problem? So you want to graph it?
You don't need, wait. Oh, I thought the graph on the bottom equals for the problem.
Oh, no, that's for the next one, yes.
What if we just find the difference between the 2 points?
Not the distance. Find the midpoint. There we go. Okay. So the midpoint. So let's see. I'm going to go ahead and just put the formula down here. So we had the sum of the x's divided by 2. Then we had the sum of the y's divided by 2. Okay, so the midpoint, I'm going to go ahead and say 1 plus 3 divided by 2. See, we're just using the corresponding values, comma. What fraction should I set up next? 2 plus 1, again, divided by 2. So it looks like my midpoint here, 4 halves, so that's a 2, and then 3 halves, so we have the fractional y value. So basically 2, 1.5. So that's the midpoint of the 2 points. Okay, but now I want to go ahead and end up with a line that goes through that point perpendicular to the other one. So what would you suggest I do now? There's something I need. I need to know the slope, okay, of the line segment connecting those 2 points. Okay. So again, change in y over the change in x. Let's see, Karime, where would you like to start, the 2 or the 1? The 2. So this time we're going to go in this direction. So 2 minus 1 over 1 minus 3. Okay. Looks to me like we're going to have negative 1 over negative 2. So it looks to me like our slope is 1/2. Yes. Remember, every now and then I like to throw in those to make sure that you're still with me. Just make sure, yes. Of course. Of course, that would come right after the fact I said I mess up every time I'm over here. Yes. Yeah, that's life. Okay, so I have the slope of negative 1/2, but we want my line to be perpendicular to this. So what slope do I need? 2. There we go. Change the sign and we go ahead and flip it. So a perpendicular slope is 2. Okay, so we're going to use this point. We're going to go ahead and use this slope. So we have point slope, or I should say point gradient. So I would probably go ahead and start there, and then we'll go ahead and put it in the form that it wants. So Peyton, using this slope 2 and the point 2 3/2, can you give me the point gradient form? Remember, that's the y minus y1 equals m parentheses x minus x1. Okay, so y minus 3/2 equals. Yes, so we need this one. Okay. All right. Now we just need to manipulate this so that it looks like our ax plus by is equal to c. Okay, who would like to come on up and show me that? Eli, you want to do it? Sure. Okay. Go. Well, everybody's enthusiastic. Maybe. Okay.
I was trying to drag it down.
Oh, here, you just like extend the screen if you want to. There you go.
Perfect. So this should equal to
Okay.
y minus 3 over 2 equals 2x minus 4. Then we just add 3 over 2. So it'll be y equals 2x.
So negative 4 plus 3/2.
Well, that's negative 5 halves, right? I'm not crazy, right? Yeah, it's negative 5 halves. Yeah, because that's 8 halves minus 3 halves. 5 halves.
Okay. Now your equation is correct, but remember we wanted standard.
Standard form, that's right. Well, I was getting there.
There you go.
This guy
Okay.
gave me a chance.
Okay. There you
So negative 2x plus y equals negative 5 halves.
Okay.
But a can't be negative, so we just multiply by negative 1 to get 2x minus y equals 5 halves.
And
Oh, do we need to add over 5 halves?
no. Now we could if you wanted to, but that's not the issue. No.
No, wait. Wait, isn't ax plus by
Equals C.
equals c?
But remember, it's one of our restrictions.
Oh, can a only be 1?
No. Oh, we're talking about the fraction.
Oh, can c not be a fraction?
Oh, no. No fractions, no decimals.
Oh, I thought only a could it be.
Oh, no. No, 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 no.
Might be. See, so we just multiply both sides by 2. It'd be 4x minus 2y is 5.
Okay.
And then, it says put my answer in ax plus by plus c equals 0.
So you could pull that 5 back over if you wanted to.
Would you like me to?
Would you like him to?
Okay. So just
4x minus 2y minus 5 equals 0. Perfect. That's it. That is standard form.
Because I kind of just wasted all of this space, you know? It's okay.
I think it works. So there you go. There's the equation of a line that is a perpendicular bisector to the line segment AB. All right. Good. Good, good, good. Okay. Questions? Hey, so. Okay. Oh, just pulled the 5 halves over? You could have. But the way I also talked to you about it, we're following those 3 restrictions. Now, more than likely, they're probably not going to do that on the paper exams, should a problem like this show up, but I always think it's still a good idea. Okay. All right. Questions? Eli.
So on the paper exam, if I just left my answer as negative 2, as 2x minus y equals 5 halves, would I still get, like, some credit, just not all of it?
You talking about this one right here?
Yeah.
Equals to 5 halves? Honestly, I mean, I don't know that they are looking specifically at the 3 restrictions. I think it really depends on the grader who has your paper. If they're really specific, like if the instructions were to say ax plus by plus c equals 0 and you left it like that, if I were grading the paper, I would still give you full credit. But you don't know if there's that one stickler who's going to go ahead and take points off of that. Because, I mean, you are still correct, so you shouldn't be losing a lot, if anything, I would think. But, again, it depends on who grades your paper. Mm-hmm. Yeah, same thing. You know, I'm always really nervous about the internal assessments because it's almost like I have Big Brother looking over my shoulder. You know, because I'll grade them, and then after, 3 or 4 weeks, IB will come back and say, okay, we want these students' papers. And then they have their own grader go through, and then your scores are changed based on whatever that grader believes. So, and last year I was told that I was way too generous. And I thought I was being strict, so we'll see. So I'm just grading them according to the rubric, doing the best I can, and just leave it in the hands of some unknown grader. Okay. Now that kind of went off topic a little bit, but I mean, it's really the same idea. Okay. Anything else? Okay. Well, let's go back up here. Whoop, that is the wrong side of the pen. Okay. Let's come back up here. All right. So now we have this problem with the grid. Show the triangle ABC, where A is negative 14, negative 1, B is 10, negative 3, and C is 6, 7, is a right triangle by finding the slopes of all 3 of the segments. Okay, and then go ahead and graph the triangle. Okay, well, it should be pretty obvious if we go ahead and graph it. Let's see here. Okay, 1, 2, 3, 4, 5, 6. So negative 14, negative 1. So let's say A is right here. Then we have 10, negative 3. So there's B. And then C is 6, 7. Okay, there we go. Let me go ahead and connect these. I don't know why it's doing it. Okay. Interesting. Let's try that one more time. What the heck? Okay, let me put in this down here. That is not what I wanted to do. Okay, I don't know why it keeps jumping like that, but imagine that it connects A to B. Okay. And you can probably tell which one is the right angle. It's got to be what? Got to be C. Okay, so let's just get somebody up here to go ahead and find those slopes real fast. Should be relatively simple problem. You're just finding the slope of basically 3 line segments, and you're looking for 2 of those slopes to be what? Okay, perpendicular, so they need to be opposite reciprocals. Okay. And again, I actually thought about this problem prior to class starting. I was wondering if I was going to show it to you or not, because it is pretty graphic. Yeah, come on. That's a good one, right? Dang. It was, but it's still, there was a lot of silence and a lot of like head shaking and eye rolling, so I don't know. Okay, but I'll take what I can get. Anyways, who would like to come on up and show me how this works? Okay, so we need to find the slope of AB, we need to find the slope of AC, and then we need to find the slope of BC. Okay. So I'm not seeing any hands, so I'm coming on over to the random number generator. I wonder if I tried this maybe with the mouse, if it would let me do that. Let me try that one more time. Hey, it actually worked. There we go. Good. Okay. All right, so let's see here. So no volunteers? 16. Is that Eli? Okay, so Eli just came up. 17. All right. It's like winning the lottery, getting come on up here. Okay. Okay.
Right?
So far, so good.
So that's the slope
Okay.
for.
So that's the slope for AB. Okay, negative 1/12, I'd agree. Okay. What do you guys think?
Not right?
Okay.
What?
There we go.
Oh, duh.
Okay. And BC, last up. So it's AC and BC that we're going to be looking at according to the diagram. So she got negative 5/2, I would agree. So we do see that segments AC and segment BC are perpendicular to each other. Yes, they have opposite reciprocal slopes. That's it. Perfect. Thank you. Okay, good. Okay. So it doesn't quite look it in the diagram, but that would be a 90-degree angle. Okay, perfect. All right, so the remainder of this is pretty much just review. There's nothing else that's new in this lesson. So there are going to be questions where you're writing different forms, given different bits of information throughout this page. You'll also notice that the last page spirals systems back in. Okay. So I'm going to go ahead and leave this up to you guys. I've got 158. We could even continue it on Thursday if you would like to, but whatever you think is going to be most beneficial. Is there any problem on here that you were looking at? You're thinking maybe I would need a little help on that? Do we need to review a system, a particular method? What do you think would be best for you guys? Because after this, we're moving on to Trig, SOHCAHTOA.
There's this system on using matrices,
Uh-huh.
and I forgot how to use matrices.
Okay. Let's do that. Now, if you were going to go ahead and do this, I would say, like this first one right here, I just want to go ahead and bring this up. The only way I would graphically solve a system is if you were using technology. Right? Even if you're trying to make it as accurate as possible, your still odds are going to be a little off. So I would definitely use technology on that. But let's take a look at this system here. Solve the linear system using matrices. Okay, so the first thing we're going to do, let's put it in standard form according to what we're accustomed to. So I'm going to say 2x minus y equals negative 2, and x plus y is equal to negative 1. Now we're going to solve it using matrices, but actually what method would work really well? Substitution would work, but I'm thinking elimination, because if I add the two right now, those y's cancel, you'll immediately have x. Okay? So that, I mean, I just want to make sure in case I'm sure somebody noticed it. But let's go ahead and write out the matrix equation. Do you guys remember this form? A times x is equal to b, where a was your coefficient matrix, okay, x was your variable matrix, and b was your, start with a C, constant matrix. Okay, so we called it the coefficient matrix because we made it directly from the coefficient. So the top row being 2 and negative 1, and then we have 1 and 1. So there's matrix A times. Now we have matrix X, which contains your unknowns, your variables. So there's your X and Y. Okay. And then we set it equal to the constant matrix, where we have negative 2 and negative 1. Okay. Now here's the thing. I mean, there's a variety of ways to go ahead and use inverses. In fact, we could find the inverse by hand. It's actually just 1 divided by the determinant times, and then you have to manipulate the elements in a particular way. Does anybody want me to even go through that, or does it matter? Anybody know what I'm referring to? Has anybody ever solved a matrix by hand by actually finding the inverse? Okay. All right, so I'm probably not going to go ahead and worry about it because you're not going to have to do that on here. I would probably just go ahead and use the technology. But if you're looking to solve for x, okay, what you want to do is take the inverse of matrix A and multiply it by B.
Oh, yeah.
Do you remember that? It's been a while, but we did look at that in here. Okay. So now let's go ahead and put it in the calculator. All right. So I don't even need to go ahead and store them in the calculator like we would a table or something for chi-squared. So what's the dimensions of A? 2 by 2. So I'm going to come on over here. Now remember over here between 9 and the catalog button? This button right here. Okay, you already had some matrix templates here, and there's a 2 by 2. So let's see, it was 2, negative 1, what was it, 1 and 1? Okay, so there's matrix A. Now, once you move your cursor outside, bless you, I want to raise it to the negative 1 power. And then right next to it, I'm going to go ahead and put matrix B. Okay, and that matrix was a 2 by 1. Okay, remember, it's always rows by columns. And what was it, negative 2 and negative 1? Okay, so you just type in A inverse B, and it'll go ahead and provide the solution for you. Okay, negative 1, 0. Now remember, that's way more work than is really necessary because you'll be allowed the calculator on both exams, and you could do what? Yeah, you could just go ahead and type in the equations as you see them, no matter what form they're in. Eli, you look surprised. We did go over this. We did go over this in class, right? Yeah, I thought so. Oh, okay. Okay. Oh, yeah. Okay. All right. So is there anything else on that set of notes that we wanted to look at? Okay. Systems, any form of a line, anything of that nature. Everybody feels pretty good? Okay. All right, so I do have a homework assignment that goes with this. I'm not going to go ahead and give it to you right now because you got the other homework assignment unless you just want me to. My plan was to go ahead and give it to you on Thursday. What would you like? You want me to wait till Thursday? Okay. What's that? I'm thinking probably Monday unless you guys are okay with the one-day turnaround on Friday. Okay, so I'll give it to you Thursday. We'll make it do Monday. Okay. Sounds good.